Alright, ladies and gentlemen, if I want to draw this graph, y equals 1/2 to the x power. Again, I recognize that this is an exponential function. The base is a positive number not equal to 1, and it's raised to the x power. I'm going to let the calculator do my work for me. Y equals, in parens, I'm going to type 1 divided by 2. I'm going to close paren, so there's my 1/2, and I'm raising it to the x power, and I'm hitting graph. Alright, so what we get this time is an exponential function, but the difference is, when you draw this, we still have the ordered pair 0, 1 as the y-intercept, but this time the graph is decreasing rather than increasing. As you go from left to right, it gets tinier. And of course the line, this line, y equals 0, still acts as my horizontal asymptote. So the domain, when I scan from left to right, I still get all reals. The range, from 0 to infinity, but of course not including 0. The equation of the horizontal asymptote is still the line y equals 0. And what kind of functions does this represent? There are actually two correct answers here. This is called an exponential function. That's because the base is a positive number not equal to 1. This graph is also referred to sometimes as a decay curve. And the reason we call it a decay curve, even in the past I've called some of them growth curves, the reason this is called a decay curve is as time gets bigger, pretend you were measuring time and let's say the amount of bacteria you had in a culture, it's decreasing. So this is sometimes referred to in real world problems as a decay curve. And we're done.